Hello everyone. We are going to do our data mining and data warehousing project assignment 1. That is our problem statement is clustering model to identify high crime areas, which is assigned by our guide Anusha ma'am. Uh, Meet my teammates, that is GP Akash, SK Karthik and Vaibhav GP and myself Abhishek PS. Now introduction. Crime is a growing concern affecting the safety, economy, and overall quality of life in cities. As urban areas expand, the volume and complexity of crime related data continue to increase, making traditional analysis methods less effective. To address this, the data mining and machine learning techniques offer modern solutions for extracting actionable insights. Among these, clustering is particularly effective in identifying hidden spatial patterns within the crime data, helping reveal crime hotspots that may not be obvious through manual observation. This enables a shift from reactive to proactive policing. Law enforcement agencies can use these insights to allocate resources more efficiently. Next is our problem statement. Large crime data sets remain underutilized due to lack of analytic tools. Traditional monitoring methods are time consuming and prone to error. High crime zones may remain undetected without spatial analysis. Manual methods lack consistency and scalability. Automated clustering can efficiently map and analyze crime concentrations. Next project objective will be done by Akash JP.
Thank you. Thank you, Abhishek. The next is the project objective. Develop a crucial based model to detect the high crime urban areas and analysis historical crime data to find a temporal pattern. Next, implementing the K meaning and algorithm to find a meaningful cluster. Comparing clustering technology using matrix like Silotics score provide actionable insight for law empowerment and city planning. The next slide, dataset and tools used. Dataset source, Chicago crime data, NYC open data, etc. The next is file used, crime type, latitude, longitude, data and district. The size is over 1000 record analyze. Tools, Python, Pandas, and etc. are used in this, and libraries assigned in the pre-processing, modeling and visualization. The next slide is a data pre-processing. Remove null or inconsistent entries to clean the data set. The next one is focused on location, coordinates and crime type for clustering. Converted timestamps to extract additional features, example hour and day. Normalized data to ensure uniform scaling in clustering models. Prepare data for scalability by filtering irrelevant fields.
After pre-processing the crime data, we applied multiple clustering algorithms to identify meaningful patterns. Uh, K-means was our primary algorithm. It's widely used and requires us to specify the number of clusters K. To determine the best value of K, we used the elbow method and found that K is 5 was optimal. We also implemented DB scan, a density based algorithm. It's particularly useful because it detects arbitrary shaped clusters and doesn't require us to predefine the number of clusters. It also handles noise in the data quite efficiently. For comprehensive analysis, we included hierarchical clustering. It helps in evaluating model performance by visualizing the dendrogram structure, which shows the relationships among clusters more clearly. These varied approaches gave us a better understanding of how crimes group separately and temporarily in the dataset. The next slide is visualization and mapping. To make the clustering results more intuitive and actionable, we used Folium and GeoPandas libraries to visualize the crime data on maps. Heat maps and marker clusters were generated to pinpoint high crime hotspots. The visualizations include interactive maps that help in understanding the spatial distribution of crime clusters across different regions. The visual representation allows authorities to easily interpret and identify high crime zones, facilitating more informed decision making. We also marked specific district and zones that showed recurring incidents, enabling targeted surveillance or intervention. Overall, the visual tools not only enhance interpretively but also bridge the gap between raw data and practical insights. The next slide will be continued by my friend Karthik. Thank
Uh, Thank you, Vaibhav. And next is the clustering results, where k means have a k is equal to 5, and we have a score of CLOT, where the clear division between zones will happen and clear mapping information is done. And DB scan also use a shielded score of 0.67, discovered 4 main clusters and noise, where it clears all the noises of the noises in the maps and makes very clear information to allocation of an patrols. And in hierarchical clustering, where a less defined clusters are happen, and most crime found concentrated near urban instructions and downtown are cleared. And DB scan perform best in a noisy and complex urban layouts, where it gives a perfect image of the urban, where allocations are done by the patrols. And in next conclusion and future scopes are clustering efficiently uncovered spatial crimes patterns and hotspots, where the hotspots are detected early before everything, and where allocates the patrols. And K means and DB scan provide scalable and interpretable outputs, where they help in the mapping and clear image of the hotspots. And DB scan shows superior performance in the space and dense environments. It have a more environment where clear and mapping functions are done. And in model results can aid in a patrolling and crime prevention strategies, where this helps in early detection and lowers the crime before it happens. And in future us integrate time series analysis and real-time hotspots tracking, where it enables live tracking of the hotspots, and uh, patrolling allocations are done efficiently. By this, our project completes, and thank you.